Hey everyone, and welcome back. We're diving into a topic that I find really fascinating, merging large language models.
LLM?
LMs. You got it? You know those AI things that can write poems or code, even answer your crazy questions.
Yeah,
And well, we're talking about how we can combine the strengths of those models to make something even more amazing.
right.
And you sent in this research paper called Activation-Informed Merging of Large Language Models that's tackling this exact idea.
Yeah.
So I'm super excited to unpack it with you.
It's a really exciting area of research because imagine, being able to take all the best parts of different AI models
Right.
and blend them all together,
Yeah.
like making the ultimate AI dream team.
Yeah, it's like you have a team of specialists in AI, and one's like a master chef, another's like a coding whiz, and another one's a language genius.
Right.
And then somehow we merge all their skills into one super powerful AI.
Exactly.
But, okay, let's start with the basics. The paper mentions these things called foundation models.
Uh-huh.
What exactly are those?
So think of foundation models as like the basic building blocks of specialized AI.
Okay.
They're trained on tons and tons of data, and they can kind of handle a wide range of tasks.
Yeah.
But they might not be experts in any one area.
Right.
It's like having a multi-tool.
Uh-huh.
It can do a lot of things okay, but it's not going to replace like a specialized tool for a specific job.
So like a Swiss Army knife.
Exactly.
Got like a little saw and a screwdriver, a bottle opener.
Yeah.
It's handy, but I'm not going to build a house with it.
Exactly. And that's where like fine-tuning comes in. It's like taking that Swiss Army knife and adding a super sharp surgeon's scalpel attachment to it.
Right.
You're taking that foundation model and then you train it further on a specific data set,
Yeah.
honing it for specific tasks like, writing different kinds of creative text formats, understanding and responding to like complex instructions, or even generating computer code.
Okay, so now we've got these specialized models that are really good at their one job.
Right.
But what happens when we need them to be more well-rounded?
Right.
That's where merging comes in.
Exactly. LLM merging is all about, combining those specialized skills into a single model.
Okay.
Kind of like creating that dream team we were talking about.
Uh-huh.
And the buzz around merging is growing rapidly for a few key reasons.
Yeah, well, from what I read, merging can potentially save a ton of storage space.
Absolutely.
That seems like a pretty big deal.
It is a big deal. Think about it. If you can combine, the abilities of 10 specialized models into one,
Right.
you suddenly need a lot less storage.
Right.
That means we can potentially run powerful AI on smaller devices like smartphones
Right.
without needing massive servers.
Wow, so instead of relying on some giant AI brain in the cloud,
Yeah,
we could have powerful AI right in our pocket.
exactly.
I bet this also makes AI more accessible for people who don't have access to those giant servers.
For sure.
Yeah, okay, cool. But storage isn't the only advantage, right? Merging can also help AI generalize better to new situations.
Okay.
So the AI is less likely to freak out when it encounters something it hasn't seen before.
Exactly. Imagine like an AI doctor that's been trained on a massive data set of medical knowledge.
Right.
But then it encounters a rare disease that it's never seen before.
Oh, no.
A merged model with its combined experience from different specialized models
Right.
would be more likely to adapt and make a more accurate diagnosis.
Wow, that's incredible.
Yeah.
Okay, so I'm definitely starting to see why this whole merging thing is such a big deal.
Yeah.
But how does it actually work? Are we like literally smashing these models together?
Not quite smashing, but it's actually not too far off.
Okay.
The paper mentions a few different merging techniques.
Okay.
There's one called model soup, where you're essentially averaging the settings or weights of different models.
So it's like we're blending the ingredients of different recipes together to create a new dish.
Yeah,
But maybe we're not really sure how it's going to turn out.
that's a great analogy.
Okay.
And then there's task arithmetic, which uses vectors to kind of guide the model towards specific tasks.
Okay.
Think of it like giving the AI a set of directions. Take these skills from model A, combine them with these skills from model B, and now go solve this problem.
Okay, that makes sense.
Yeah.
But there's another method mentioned in the paper called widen. And honestly, I'm not quite sure what it's all about.
Widen is a bit more complex. It involves disentangling the different components of a model's weights.
Okay.
Imagine trying to separate the different instruments in a symphony orchestra
Okay.
so you can understand each one's individual contribution.
So it's like breaking down the AI's brain into its individual parts.
Yeah,
To see how they all work together.
exactly.
Okay, I think I'm starting to get the picture.
Yeah.
But there's a twist, right? This research introduces a whole new element to the merging game,
Right?
the activation space.
Yes.
Can you explain what that is and why it's so important?
Absolutely, it is a game changer. Most merging techniques focus just on the model's weights. Those settings that we were just talking about.
Uh-huh.
But this research says, hey, let's not just look at the settings, let's see how those settings actually affect the AI's thought process.
Okay.
And that's where the activation space comes in.
Okay, so I'm trying to wrap my head around this activation space. It sounds kind of mysterious.
Right.
Can we break it down a bit
Yeah,
further?
think of it like a symphony orchestra again.
Oh.
Each instrument or weight contributes to the overall sound,
Mm-hmm.
which is like the AI's output.
Yeah.
The activations tell us, which instruments are playing the loudest
Right.
and most crucial parts for like a specific piece of music
Okay.
or task.
So it's not just about tweaking the settings of the AI,
Right.
but about understanding how those settings affect the way that the AI thinks.
Exactly.
Okay.
And what's really fascinating is that by looking at the activation space, we can identify what are called salient weights,
Okay.
the ones that are absolutely crucial for a model's performance.
So it's like figuring out which instruments are carrying the melody and which ones are just providing background harmony.
Exactly.
Okay.
We want to make sure that we keep those key players in the spotlight during the merging process.
Right?
And this is where the research gets really interesting. They use a special calibration data set to pinpoint those essential weights.
Okay.
It's like a test kitchen where they can experiment and see which weights are truly making a difference for different tasks.
So they're figuring out the AI's secret sauce,
Exactly. And that knowledge is what makes their proposed merging methods so powerful.
which is drumroll, please.
Activation-informed merging, or
Okay.
AIM.
AIM, it definitely sounds like something out of a spy movie. So how does this activation awareness actually play into the merging process? What makes AIM different?
Well, imagine you're teaching a brilliant chef a new recipe.
Okay.
You wouldn't want them to completely forget everything they already know about cooking,
Well,
right?
of course not. They'd be lost without their foundational skills.
Exactly. It's the same with AI. When you merge models, you want to ensure that the new combined model
Right.
doesn't lose the core abilities of the original models.
Okay.
And that's what AIM helps to do.
So AIM is like a safeguard,
Yeah.
making sure that the merged model keeps its general knowledge while also gaining these new specialized skills.
That's a great way to put it. And it actually relates to a concept called catastrophic forgetting in AI research.
Catastrophic forgetting.
Yeah, imagine you have an AI that can recognize cats and dogs,
Okay.
but then you train it to recognize birds, and suddenly it forgets all about cats and dogs.
Oh, no, that's terrible. Poor kitty and pup.
Right, it's a problem, and AIM helps prevent that from happening during merging.
Gotcha.
By understanding which weights are crucial for the base model's knowledge, AIM makes sure that those weights are protected and preserved
Okay.
during the merging process.
So AIM is like the master conductor, making sure that the orchestra stays in harmony even as new instruments are added to the mix.
Precisely.
This is all sounding pretty impressive, but I know our listeners probably thinking the same thing I am. How well does AIM actually work?
Right. Well, that's what the researchers set out to discover.
Yeah.
They tested AIM on a variety of tasks, things like reading comprehension,
Okay.
answering open-ended, challenging, or strange questions, and even writing computer code.
Wow.
These are all real-world applications of AI, so it gives us a good sense of how AIM would perform in practice.
Okay, I'm on the edge of my seat. What were the results? Did AIM live up to the hype?
You bet it. Did AIM consistently improve the performance of the merged models?
Tell us, tell us.
And often by a significant margin. For example, on one benchmark that tested their ability to generate computer code, some merged models saw improvements of over 85% after applying AIM.
Wow, that's a giant leap forward. It seems like paying attention to the activation space really does make a difference. But wait, I remember seeing something in the paper about a hypervolume gain metric. What in the world is that?
That's a great question. It's all about how we measure the success of a merged model. It's not just about being good at one specific task,
Right.
but about finding a balance between all those different skills. Think of it like an athlete who excels in multiple sports. They're not just a sprinter, but they're also a swimmer and a gymnast.
Okay.
They have a diverse skill set,
Yeah.
which makes them a much more impressive athlete overall.
So it's not about winning in one area, but about being a well-rounded AI athlete.
Exactly. And the hypervolume gain metric captures that idea.
Okay.
It gives us a more holistic view of how well a merged model performs across all the different tasks that it was tested on.
Right.
And the exciting thing is that AIM consistently improved this metric as well, showing that it really can create more balanced and versatile AI models.
That's fantastic. So it sounds like AIM is already showing a lot of promise. But the researchers didn't stop there, did they? The paper mentions something called an ablation study, which sounds a bit intimidating, but I'm curious to know what they learned.
It's actually a pretty straightforward idea, but it has a fancy name. In an ablation study, researchers essentially tinker with different parts of their method to see how it affects performance.
Okay.
It's like taking apart a clock to see how each gear contributes to keeping the time.
So they were fine-tuning the fine-tuner.
Exactly. And in this case, they focused on something called the relaxation factor.
Okay. Now, that definitely sounds complicated.
It's not as complex as it sounds. Think of it like a dial that controls how tightly AMAM holds onto the core knowledge of the original models during merging.
Okay?
If you turn the dial up too high, the merged model might be too rigid and not learn anything new.
Right.
But if you turn it down too low, it might forget too much of its original knowledge.
Gotcha.
The researchers were trying to find the sweet spot.
So they were looking for the Goldilocks setting for the relaxation factor.
Exactly. And what they found was that a setting around zero point 0.4 seemed to work best in most cases.
Okay.
But here's the interesting part. Even with more extreme settings, they sometimes saw benefits, which suggests there's even more room to explore and optimize this approach in the future.
It's like they discovered a hidden treasure chest of AI potential.
Right.
And it's all thanks to this new way of thinking about merging, taking into account the activation space. This deep dive has already taught me so much about the frontiers of AI research, and I'm eager to hear more.
Well, hold on tight because we're just getting started.
Okay, I'm ready for part 2.
Okay. This research has really opened up a whole new world of possibilities for developing even more powerful and versatile AI.
I was just thinking that we've been talking about how merging can save storage space and create AI that can adapt to new situations.
Right.
But what are some other ways that this could impact our lives? I'm dying to hear some real-world applications.
Well, one area that's particularly exciting is personalized AI assistance.
Okay?
Imagine having an AI that's tailored specifically to your needs and preferences.
Yeah.
Like a super smart personal assistant that knows you better than you know yourself.
Okay, that sounds amazing. But how would merging make that possible? I'm picturing a team of tiny AI robots, analyzing my every move.
Not quite robots, but you're on the right track.
Mm-hmm.
By merging models that are fine-tuned for specific tasks,
Okay.
you could create an AI assistant that can handle everything from managing your schedule and recommending movies to helping you learn a new language or even providing emotional support.
Wow.
It'd be like having a team of specialized AI experts
Right.
all working together to make your life easier and more fulfilling.
Wow, that would be incredible. I'm already thinking about all the things I could delegate to my personalized AI assistant. So instead of having a bunch of separate apps for different things, I could have one AI that does it all.
Right.
And it would learn my preferences over time.
Exactly. It would be like a seamless and intuitive way to interact with technology.
Yeah.
And as AI models continue to improve, the possibilities for personalization become even more exciting.
Okay, I'm sold. Sign me up for the personalized AI assistant of the future. But this idea of decentralized AI development that we touched on earlier
Yeah.
is also really intriguing. Do you tell me a little bit more about that? I'm not quite sure I grasp how merging could lead to a more decentralized AI landscape.
Right now, developing powerful AI models often requires massive amounts of data and computing power,
Uh-huh.
which are typically concentrated in large tech companies.
Right.
But merging could change that. Imagine a scenario where smaller teams or even individuals
Wow.
could develop specialized AI models and then contribute them to a global pool of AI knowledge.
So instead of having a few giant AI corporations controlling everything, we could have a global network of AI developers all contributing their expertise.
Exactly.
That sounds amazing, but how would merging play into that?
Well, merging would allow us to combine those specialized models from different developers
Yeah.
into larger, more powerful models. It's like crowdfunding for AI.
Right.
Instead of needing a huge budget and resources to create cutting-edge AI,
Yeah.
we could pool our collective intelligence and create something truly extraordinary.
It's like open source software, but for AI. I love that idea. It would democratize access to AI and accelerate innovation. What are some other fields where you see merging having a big impact?
The potential applications are vast. In healthcare, we could merge models trained on different medical specialties
Uh-huh.
to create AI that can diagnose and treat a wider range of conditions.
Okay.
In education, we could create personalized learning experiences that adapt to each student's individual needs and learning style.
Right.
And in creative industries, we could merge models trained on different artistic styles to generate new forms of art and music.
This is blowing my mind. We're talking about a future where AI is not just a tool,
Right.
but a collaborative partner, helping us solve complex problems and unlock our creative potential.
Exactly. And it's important to remember that we're still in the early stages of this research.
Yeah.
As we continue to explore the possibilities of merging and learn more about the activation space, we're likely to see even more groundbreaking applications emerge.
This reminds me of the early days of the internet. People knew it had the potential to change the world, but they couldn't have predicted all the ways it would impact our lives. It feels like we're at a similar inflection point with AI.
That's a great analogy. We're standing on the cusp of a new era,
Yeah.
and merging LLMs is one of the most exciting developments driving us forward.
This deep dive has been truly inspiring. I'm already thinking about all the ways that this technology could shape the future.
It's a journey we're all on together, and the more we learn and explore, the better equipped we'll be to navigate this exciting and rapidly evolving world of AI.
Well, this has been an incredible journey so far, and I know our listener is eager to hear what else the researchers discovered about AIM.
They definitely dug deep.
Okay, let's dive into part 3. So we've talked about all the potential of AIM, but did the researchers uncover any limitations or areas where it might not be like the best approach?
Yeah, that's where their thoroughness really shines through. They didn't just stop at demonstrating AIM's successes. They actually went a step further and explored scenarios where AIM might not be the ideal solution.
Okay, now that's what I call due diligence. I'm all ears. What did they find?
Well, they discovered that when dealing with certain types of specialized models, particularly those with very distinct and narrow areas of expertise,
Right.
the merging process could sometimes lead to a slight decrease in performance on very specific tasks.
Okay.
It's like trying to combine a world-class pastry chef with a master sushi chef.
Uh-huh.
The fusion might create some interesting new dishes, but you might lose a bit of the precision and finesse
Right.
of each individual chef's specialty.
That makes sense. Sometimes it's better to have dedicated experts rather than trying to create a jack of all trades.
Exactly. And the researchers were very transparent about these findings, which is crucial for advancing the field responsibly.
Yeah.
They acknowledged that AIM isn't a one-size-fits-all solution.
Right.
And they highlighted the importance of carefully considering the specific characteristics of the models being merged.
So it's about choosing the right tool for the job, just like in any other field.
Exactly.
It sounds like this research is a really valuable contribution to the ongoing conversation about the best ways to develop and deploy AI.
Absolutely.
It's not just about creating bigger and more powerful models,
Right.
but about understanding how to use them effectively and responsibly.
Precisely.
Well, you've definitely given me a lot to think about. This deep dive has been incredibly insightful, and I feel like I have a much better grasp on this exciting new frontier in AI research. Before we wrap up, is there anything else you'd like to share about the future of merging or any key takeaways for our listener?
One thing that really struck me about this research is its potential to not only advance AI capabilities,
Mm-hmm.
but also to make AI more accessible and democratic.
Okay.
Imagine a future where anyone with a good idea and access to some computing power can contribute to the development of cutting-edge AI.
Yeah.
That's a future I'm excited to be a part of.
It's a future where AI truly becomes a collaborative endeavor driven by a global community of innovators and problem solvers. And that's a vision that's both inspiring and empowering. So to our listener, thank you for sharing this fascinating research paper with us. Your curiosity and engagement are what fuel these deep dives. And we appreciate you being on this journey with us. Keep those submissions coming. Until next time, keep on diving deep.